All right, so let's continue our lecture 2.3, more graphs of quantitative data. So last time we talked about different graphs. We started with, what was 2.1? Do you remember? That was 2.1, anyone?
Is it the graphical summaries 2.1?
So yeah, so the graphs of qualitative data, and we use, what are those graphs? What do we use to graph those qualitative data?
The pie charts, the side-by-side bar, and the horizontal bar.
Yeah, so the pie chart and the histograms. Is it the histograms? And then 2.2 quantitative data. You learn 3 graphs. What are those? Oh, quantitative data, those are histograms, frequency, polygon, and the ogives. So 2.1 qualitative data, so the bar graphs and the pie chart, right? So now we're going to continue our quantitative data, the graphs. We have here, these are the objectives. Construct stem and leaf plots, then dot plots, and the time series plots. So again, these are the graphs for quantitative data. So let's start with stem and leaf. If you want to copy this, stem and leaf plots are a simple way to display small data sets. So it's easier if you have a small data set, it's easier to use either stem or the box plot. So the first one is stem and leaf plot. The rightmost digit is the leaf, and the remaining digits are the stem. So let's say, for example, you have here 14.8 and 2,739. So we can consider the whole number here, 14, as a stem, and 8 is a leaf. And here for 2,739, we can treat as the first 3 digits, 273, as a stem, and the last one as a leaf. So that's the stem and leaf plot. So let's say we have an example here. The following table presents the U.S. Census Bureau projection for the percentage of the population ages 65 and over for each state and the District of Columbia. So construct a stem and leaf plot. So how are we going to do that? So notice on these data, these are quantitative data. So we have 14.1, 8.1, up to 14.0. What is the lowest here?
Hey, 2.1.
Is it 8.1 here? And the highest?
$17.8.
Where is that? 17.8. All right, so from 8 to 17, so you're gonna create your stem and leaf just like this. This is 14.8. You have a stem here, 14, and the points 0.8 is a leaf. So stems are from 8 to 17. So you're gonna write down 8, 9, 10, 11, 12, 13, 14, up to 17. And then the rest, you're gonna tally all the leaf of each state here. So let's say this one, 14.1. So you're gonna look for 14 and then write 1 here. Next, 8.1. So the leaf is 1, so just write 1 here. Next, 13.9, look for 13, and then the number is 9, so you have to write number 9. The next 14.3, so it's going to be 3 here. 11.5, so 11, and the leaf is 5. Next, 10.7, so 10, 7. 14.4, and so on and so forth, everything. Up to 14.0, there's going to be a 0 here. Did you get that? So you're going to tally the leaf of each state for all these stems from 8 up to 17. We're not done yet. What you're going to do next is, after you do that, you arrange the numbers in order. Like this one, you see 1, 3, 4, 0. So you have to erase it and arrange it in order. So you're going to write it like, should be like 0, 1, 3, 4.
I'm sorry, how did you get the 1340 from?
Oh, these numbers here?
Yes.
All right, so again, all right, so lowest number is 8.1, highest is 17.8, right? So that's going to be your stem. So your stems you have from 8 up to 17. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, okay? Next is you're going to tally all the leaf of each state here. So let's say the first one, 14.1. The leaf is 1. So look for 14 and write 1 here. Next, Alaska, 8.1. The leaf is 1. So look for 8, and this is 1. Write 1. Next, 13.9. So look for 13. So this is 13. The leaf is 9. So write 9. Next, 14.3, the leaf is 3, so write 3 here. So that's why you have the numbers 1, 3 here. Next, 11.5, 11, so look for 11 and write 5 here. Next, 10.7, 10, 7, 14.4, so that's why you have 4 here. 14.1, that's why you have another 1 here. 11.5, another 5 here. 17.8, so look for 17 and you're gonna have 8 here. 10.2, 14.3, 12.0, and so on and so forth.
Got it. And then what we do is we just arrange the stem, put the stem in the right category after.
So here on the
Order.
next, all you have to do is arrange the numbers the right side, all these green numbers in order.
Got it.
So, oh, we have it here. So when you tally all those, you're gonna see something like this, right? Just like what you saw for 14, 1, 3, 4, 1, and so on and so forth. Then again, arrange it in order, in increasing order. So 8, 1, 9, 0, 7, 2, 5. Arrange this in order. So that's why it's going to be 2, 5, 7. 5, 5. Next one, arrange this, 0, all these numbers in order. So the lowest is 0, then 2. There are 2 2s, 3, 1. There are 4 4s, 2 6s, 1 7, 2 8s. Arrange this in order. This one, everything. 6 0 3 5 is going to be 0 3 5 6. Okay. So now this is the answer. This is your stem and leaf plot. Okay, the reason why you are doing this and you are arranging this in order is easier to read this. Let's say you talk about those with 50 states and DC. You read, how you read this is like you have 8.1 here. When you combine 8 and 1 here, meaning that is 8.1. This one is 9.0. Let's say from 12, look at these numbers, meaning this is 12.0, 12.2, 12.2, 12.3, 12.4. You have 4 12.4s, you have 2 12.6s, you have 1 12.7, and you have 2 12.8s. Okay? Any questions? No questions? All right, so how about a back-to-back stem and leaf plots? So you can do this when two data sets have values similar enough to the same stems can be used, and then we can use a back-to-back stem and leaf plot. Just like for this, if you have consider the following course averages from an English class and a history class, then classes can be compared with a back-to-back stem and leaf plot. So like this one for English, lowest is 45 and highest is 91. It looks like it's arranged in order. For history, lowest is 59, highest is 100. It's arranged in order, the grades. So you can use the stem and leaf plot here from 4 to 9. Lowest is 45, highest 91, so that is from 4 to 9. The history is lowest 59 up to 100, so from 5 to 10. So this is your stem, 4, 5, 6, 7, 8, 9, 10. Then now you can tally all these numbers, 45, so that's why you have 45 here. Next 57, 62, 66, 68, 69, 72, 74, another 74, 76, 77, 79, and the last one, 91. So the other side, which is this history class, you started at 59, so that's why you have 59 here. Then 61, 61, 67, 71, 71, 73, 80, up to 88. Then you have 92, 97, 98. And the last one, 10 and 0, meaning that is 100. So this is a back-to-back stem and leaf plots. Questions?
Yeah, what's the particular benefit of using this kind of tracking system?
A lot, actually. First, it's easier to, since I mentioned earlier that if you have a small data, just like this, you only have 1, 2, 3, 4, 16 per class. So instead of using like what we did last time, histogram or what else? Frequency polygon or the ogive, it's easier to use an easy graph like stem and leaf plot, and the other one box plot. And next one is next section actually, or next chapter about the measures of center is going to be easier for you to solve for the mean, median, and the mode, something like that. Because you're going to need this for the next sections and next chapters. Okay.
Okay.
Because in math we want to know we want to study about, let's say, about this English class, these numbers. How what can you say about these class averages, like these numbers here? What can you say about these class averages?
They're similar enough.
And also remember last time we used a bell-shaped curve. The reason why you need to arrange it in order, you can also use a bell-shaped curve here, just like for the like something like this. Is it going to be symmetric or skewed to the right or skewed to the left? So you can also do that. And like what I said, for the next chapter, you're going to learn about solving for the mean, median, and mode, or standard deviation, and a lot more. Okay. Any other questions? Good question. There's one in the chat. If don't be shy. If you can, yes, Jerry. You can always use the chat, or you can send it in private, and I'm gonna read your question. Okay. So next one, next slide. Right, dot plot. So this is another one to graph your quantitative data. Or Jack's question, on the test, how can we show a bell-shaped curve? You don't need to show it to me. Mostly, you're gonna assume what is it when you try to draw a curve. Is it symmetric or skewed to the left or skewed to the right? This one, it looks like approximately symmetric, right? So mostly when you see a quiz or on a test, I'm not gonna ask you to draw something like this. So you're just gonna type the answer like it is approximately symmetric. Okay. Yeah. And also, speaking of later, if you work, let's say you're gonna see something like this on your classwork, I'll take advantage of this. So if you have a back-to-back stem and leaf plots, so all you have to do is create 3 columns. This is your stem, and let's say this is history and English. So you just have to type the numbers. You just have to have 3 columns and type those numbers. Okay, you're gonna see a problem like this later for the classwork. So by the way, there are only 2 problems. So the first problem is just like what we did last time, just completing the table of your frequency distribution table. Remember that? So when you have your class limits and then the frequency, all you have to do is complete the table with RF, X, and cumulative frequency, and that's it. So I'm just gonna, it's a practice for your tests. Someone asked if we need to arrange the leaves in increasing order. Yes, that's one thing. You have to make sure that you arrange it in order. So just like this, everything is in order, increasing order. 2, 6, 8, 9, 2, 4, 4, 6, 7, 9. Or when we go back here, that's the reason why this is the final answer, because you arrange these numbers in increasing order. If you don't do that, you will get deductions on the test. Okay? Great question. All right, so next one, another way to graph your quantitative data is by using a dot plot. It's another simple way to show your data. As a graph can be used to give a rough impression of the shape of a data set, just like a stem and leaf plot. It is useful when a data set is not too large and when there are some repeated values. So consider the number of children here, an example, had by each of the presidents of the US and their wives. So lowest is 0, highest is 15. Who is that president? 15 children. All right, so all you have to do is from 0 to 15, you just have to draw a horizontal line, just like this, and number it from 0 to 16. Or if you want, you can number it by even numbers 0, 2, 4, 6, 8, 10, 12, 14, 16. Or it's just easy, 0 up to 15, actually. Okay, and then just tally, use dots. So 0 is 1 dot here, 2 is a dot here, 10, a dot here, 2, another dot here on top of your first dot. Okay. Where's my pen? So again, if this is your 0, so you just have to place a dot, 2, a dot here, 10 is 10 here, 2 is on top of the first dot, 5 is here, 3 is here, 6 is here, another 2, then 4, and so on and so forth. That's why you're gonna have all this. Easy, right? And also, you can use a bell-shaped curve here, just like what you did for stem and leaf plot. And obviously, this is skewed to the right. Okay? Any questions? And again, the reason why we're doing this is because you can easily interpret this. You'll see here. So a dot plot gives a good indication of where the values are concentrated and where the gaps are. So for example, it is immediately apparent that the most frequent number of children is 2 based on these dots, and only 4 presidents had more than 6. So these 4 presidents here, 7, 8, 10, and 15. So you can easily write an interpretation of that data. And that's what actually we want for statistics, right? Everything about statistics is the data and how to interpret your data. And mostly when you interpret the data, it's easier when you have the graphs. Okay? Any questions about dot plots? Okay, no questions. Next one is time series plots. So based on the name time series, so that is using the data consisting of values of a variable measured at different points in time. So with this plot, a horizontal axis represents the time. So you have the horizontal axis. So this should be the time, usually the year. And the vertical axis represents the value of the variable we are measuring. So just like an example here, the following table in the time series plot display the closing value of Dow Jones Industrial Average at the end of each year from 2003 up to 2016. So your horizontal should be your time, that is the year, based on your data here. So from 2003 up to 2016. And then your vertical line is about the average in dollars. So here you can see a lowest 10,000 should be 8,776, and then this is highest is 19,000. Do not on the vertical line here, do not write these numbers. So make sure that you have the gaps here, they're all equal. So that is like by 2000s, from 0 to 1,000, 4,000 up to 20,000. Then locate this 2003, 10,453 is approximate that. So let's say this point here. Next one, 10,783. The next one up to the last one, 2016, 19,762.60. And then connect the dots using straight lines. And that is your time series plot. Any questions? That's 2.3. Your stem and leaf plots, dot plots, and time series plots. How about let's have a quick review of so that you know what to do for your classwork. Again, you know that you have an ebook here. So that is chapter 2, 2.3. How about if we have number 22 here? So I'm gonna try to show you number 22. So pass the popcorn. So the following are the running times in minutes for the top 15 grossing movies of all time rated PG-13, and the top 15 grossing movies of all time rated R. So these are the top 15, and we're gonna construct a back-to-back stem and leaf plots for these data sets. So here, what's the for PG-13, what's the lowest and what's the highest?
121 and 194.
121 and 194. How about the other one rated R? 121 and did you say 194? And rated R?
That would be 96 and 170.
Oh, I think, yeah, 96 and 170. But is this the whole thing? Sorry. Oh yeah, there's more, but yeah, it's 170. Okay, so let's tally this. Oops, where's my ink? So let's say PG 13. So that's the first column here. And this is rated R. So PG 13, we said earlier that lowest is 121. So we have 12 up to 19, and this one 96 up to 170. So meaning we're gonna start at 9, 10, 11, 12, 13, 14, 15, 16, 17. Oops, why did I? So again, sorry, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so PG-13, 136. So you tally here, 136, so 136. Next 162, next 194. Wait, we have 19. Sorry. So 194, then 124, next 143, 152, 141, then 164. There's someone in the chat. No, it's not handwritten. That's why you're gonna do. You're gonna create tables like this. So it's gonna be a three columns, and you're gonna type PG-13, and then your stems on in the middle, and then let's say rated R here. So that's the third column. Then you're just gonna type the numbers. Now I'm lost. Where do we stop? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 164, then 146, 151, 129, 142, 147, 121, and 127. Then remember, you need to arrange this in order. So 7194, it should be 1479. So you're gonna erase it and write 1479. Okay, like this one, 1, 2. So it should be 1, 2. This is 2, 4, and 4. This one is should be 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. Okay. And you're gonna do the same thing for rated R. Any questions? Any questions? All right. So, oh, I need to show you. What if you see something? I need to clear this. So there are some questions like this one. Split. Can you see that? Like here, number 17, repeat part A, but this time split the stems. So quick example of this. So let's find out what is the lowest number here and what's the highest for the BMW prices.
The highest is 114.
The highest is 140.
Oh yeah, 140. And then
And the lowest.
30.8.
The lowest is 31.2.
31. Oh, they're next to each other.
30.8.
Oh, 30.8.
Oh yeah, my bad.
Yeah.
All right, so let's say here, round the data to the nearest whole number. So this is like 31, right? This is 141. Do you agree? This is
Yep.
31, 141. And since lowest is 31, 141, so if you write your stem and leaf, letter B, split the stems. What you're going to do is you're going to have double all the numbers from 3 to 14. So you should have 3 and 3, 4 and 4, 5, 5, 6, 6, 7, 7, 8, 8, up to 14, 14. So that's how you split it.
Mhm.
Okay. Next, that's why you split it, meaning the numbers here on the first, the numbers are from 0 to 4. And then the second is from 5 to 9. 0 to 4, 5 to 9. That's how you split it. You just split it in the middle, the numbers. Okay. So like this one, this one is this is 50. When you round off, this is 50. So that's going to be on the first 5. This one is when you round off is 9. This is 90. So let's say we have here 9 and 9. So we're going to have again a 0 here on the first 9. 55.2 when you round this, it's going to be, what is this? 50. So you're going to have another 0 here. This one, 31, is going to be 1 here. 63, 3 here. This one is 39. So that's going to be on the second 3. Next, 70. Wait, this should be 55, sorry. I said 50. 70, so 70, 48. So that's on the second 4. 89.2 is 89. So on the second 8. 47.5 is 48. So another 8 here. 86.2, so 6 here, and so on and so forth. Up to the last one. So let's say 86.8 is 87. So that's going to be 7 here. Okay, but also don't forget to arrange it in order. So you're going to erase this. It's going to be 6, 7, 9, something like that. So that is every time you see split the stems, this is what you need to do. Questions?
No.
All right. Are you sure no other questions?
I have a question. Okay, so just to clarify, so for the stem, no, for the, is it the stem? So we double the numbers, right? Okay, so we doubled the numbers on the left side.
Yes.
And we do that because if it doesn't, I guess, round to the next number.
No, we do it because it says on the problem, split the stems.
Okay.
But
Okay.
you only do that when you see this. Split the stems, meaning you double the number.
Okay, that's the only time we double it.
Yeah. Mm-hmm.
Okay.
The reason why we are rounding off numbers here, because it says here, round to the nearest whole number.
Got it. Okay.
That's part of the instruction. That's why we did it.
Okay.
Okay. Yes. So the first stem is 0 to 4. When you split it, the second is 5 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the first, the second, when you split. Okay. Any other questions? All right, no other questions. Then we can continue our lecture. Next one, 2.4. Graphs sometimes can be misleading. And what are the reasons? So these are the objectives. Understand how improper positioning of the vertical scale can be misleading. Next is understand the area principle for constructing statistical graphs. And the last one, understand how three-dimensional graphs or 3D graphs can be misleading. So all of you know how to graph with the axis y and x axis, or the vertical and the horizontal, right? We always when we graph like last time when we graph histograms, frequency polygon, or ogives, or earlier the time series, we always have the axis y and x axis, right? So these we discuss here as three most common forms of the misinterpretation. That is number one. If you want to copy this, it's up to you. So incorrect position of the vertical scale, incorrect sizing of the graphical images, and misleading perspective of 3D diagrams. So an example here, positioning the vertical axis. So the baseline of a graph is the value of which the horizontal axis intersects with the vertical axis. So look at the intersection of the horizontal and the vertical lines. So with graphs or plots that represent how much or how many of something, it may be misleading if the baseline is not 0. Look at the two graphs here. The graph on the right, they started at 47. That's the baseline. The graph on the left, they started at 0. That's why this, which one is misleading here? Look.
The one on the right.
Why?
It's starting at 47.
Yes, because it starts at 47. Look at this. When you start at 47, not at 0, it looks like there's a big difference between the bars from 2009 up to 2015, right? Well, in fact, if you change it the proper way from 0 up to 60, look at this. Look at the heights of your bars. It's almost the same. Okay, so that's why, that's the first one. It's misleading because of the the intersection between your horizontal and vertical lines. So from now on, I expect from you that it's gonna be, you should always have at 0. Okay. Next one, with a time series, it's the same thing. The same misleading information can be created with the time series plots. So look at this. It started at 47. This one is at 0. So passenger traffic at Denver International Airport. Next one is the area principle. So do you remember how to solve some area? That's the area of a square or anything. So we often use images to compare amounts. Larger images correspond to greater amounts. And to use images properly in this way, we must follow a rule known as the area principle. So if you want to copy this, so when amounts are compared by constructing an image for each amount, the areas of the images must be proportional to the amounts. So proportional. So for example, if one amount is twice as much as the other, its image should be the same thing. should have twice as much area as the other image. So look at the example here. The cost of jet fuel in 2012, you have it here, $3.09 per gallon. And in 2016, it had fallen to 93 cents. So note that the price in 2016 is about 1/3 of the price in 2012. So by looking at this graph here, the rectangle here is comparing to 2012. This is like three times of this is 2012, right? So in the bar graph, the area for the 2016 is about 1/3 of the 2012 bar. But in the planes image, look at your 2012 and 2016, the difference appears much larger. So the reason is that both the height and the width of the airplane have been decreased by the factor of approximately 1/3. So meaning the area of the smaller is about 1/9 of the area of the larger plane. So the airplane graph violates the area principle, and this is a misleading graph. Because based on our bar graph here, it should be 2012 compared to 2016. This should be 1/3 of 2012, right? But for this small airplane here is not 1/3 of this. Do you agree? So that's why this is misleading. So don't do that. You can do this with airplanes, but make sure that if you show here that it's like 1/3, so make sure that your smaller plane here is also like 1/3 of the area of this airplane. Because what happens here in the statistics is, just think about what if you don't have, just thinking about your data, what if you don't have this? How are you going to read this? So if you don't have this correct data here, you would think that, oh, comparing to 2016 and 2012, that's just a very small difference between the two. Well, in fact, it's actually should be 1/3 of 2012. Okay, so that's why it's still easier to have this type of graphs, but make it correct. Make it sure that it starts at 0. And that is very important in statistics. When you are presenting your data, when you use graphs, so make sure that, think about everyone can read your graph. Even if they know, even if they don't know anything about math, when they see it, they should interpret, they should know how to interpret what they see. So that is very important in statistics. So next one, and the last one, understand how 3-dimensional graphs can be misleading. So this is 3D. So newspapers and magazines often present 3-dimensional bar graphs because they are visually impressive. Unfortunately, in order to make the tops of the bars visible, these graphs are often drawn as though the reader is looking down on them. And this makes the bars look shorter than they really are. And as you can see here, let's say the cost of the fuel. If you look on the top view, this one looks so small, right? So they may look shorter than they really are. And that's it for 2.4. And actually, that's the end of chapter 2. Any questions?
I do actually have a question.